Hello, good morning. We are team number 1 and we are going to present the first partial project. Our team is composed by Regina, Elizabeth Zaragoza, Pamela Barajas,
Daniel Díaz.
A man invests $5,000 in an account that pays 8.5% per year. Find the amount after 3 years if the interest is compounded quarterly. How long will it take for the investment to double when compounded quarterly? If the interest is compounded continuously, how does the answer to question B changes? Express the continuous interest model as a function of time and sketch the graph of it.
For the first question, we need to find the amount after 3 years if the interest is compounded quarterly.
For this problem, we need to find out the compound interest by using the compound interest formula. A times t equal p times 1 plus r over n to the nt power. In here, at is the amount after years. P is the principal, r is the interest rate per year, n is the number of times interest that is compounded per year, and t is the number of years. In here, P is 5,000, our initial amount of money. R is 8.5%, N is quarterly, and T is 3 years. We need to find out A of T. So now with the data, we can substitute the formula. A of T equal to 5,000 times 1 plus R, and it is 0.085 because it is over 100 over 4, that is a quarterly, to the 4 times 3.
So what we do is solve the equation with the data that is given. First, we solve the 4 times 3 and the result is that we have 5,000 times 1 plus 0.085 over 4 to the 12th power. Then we solve the division between the 0.085 over 4, and the result we got is 0.2125. Then we added 1 to that result. Then we elevate to the 12, 1.02125, and the result is 1.2870. And then all that we multiply by 5,000, and with this we get that the interest after 3 years compounding quarterly is of 6,435.09.
So, the second question is, how long will it take for the investment to double when compounded quarterly? To solve this question, we need to use the same formula. AT is equal to P by 1 plus R over N to the nth power. We need to know the time for the investment to double. So, we need to substitute the values. 10,000 because it's the double of the investment, 5,000 because it's the initial number, 1 plus 0.085 over 4 to the 40. We need to get to know the t value. So we need to pass 5,000 over 10,000, which is 2, equal to 1 plus 0.085 over 4 to the 40. Here we need to use a logarithm rule, so we put log of 2 is equal to log 1 plus 0.05 over 4 to the 40. We need to pass the exponent as a coefficient and multiply it. So for getting the t alone, we need to pass this value over log to the 2, and we will have t alone. If we solve log of 2 over 4 log 1 plus 0.085 over 4, this will give me 8.24 years. So it will take 8.24 years for the investment to double.
If the interest is compounded continuously, how the answer to question B changes? So for the compounded continuous interest, we need a new formula. So this is our new formula, and 10,000 is our double capital, and 5,000 is our initial capital, e times e to the 0.085 t. So we divide 5,000 with 10,000, and it gives us 2 e to 0.085 t. And we need to put natural logarithm of 2 with natural logarithm of e, and we cancel out this one, so we are left with natural logarithm of 2, 0.085 t, and we need to isolate t, so we're left with natural logarithm of 2 over 0.085, and that gives us 8.15 years. So how does the answer to question B changes?
Well, the answer changes that it with compounded continuously we have 8.15 years, and quarterly we have 8.24 years. It changes, but it doesn't change that much. But anyway, it is still better to invest in a continuously way than in a quarterly way.
Now we need to sketch the graph to express the continuous compounded interest made as a function of time. So we introduce this function in GeoGebra, and then we obtain the graph.
The steps we used to solve this problem were: 1. Read the problem. 2. Get the data. 3. Investigate how to do it. 4. Establish a formula. 5. Establish what quadriline means. 6. Solve the questions. 7. Graph in GeoGebra. And 8. Get to the conclusion.
After solving this problem as a team, we conclude that we can use quarterly compounds to help us estimate the time we are going to need to reach an exact amount of money, and to understand the interest calculation for deposits if we work at the business or economic world. This can be very helpful for us in our futures, because that way we can calculate how much money we will earn in which amount of time.
Thank you!